Today we're working on 12.4, which is volumes of prisms and cylinders. Okay, the volume of a prism formula is big B, which is the area of the base, times the height. So basically for the volume, we're doing the area of base times the height of the prism. Let's do some examples. Okay, so for this one, it is a triangular prism. So we're doing the area of the base times the height. How do we find the area of a triangle? Area of a triangle is going to be base times height of the triangle divided by 2. Then whenever we get that, we're going to multiply that times the height of the prism. So let's go plug in numbers. Our triangle over here, our base and our height is 3 and 4. So I have 3 times 4, and that's all divided by 2. And then I'm going to multiply it times the height of the prism. And the height of the prism is the distance between the two bases. So times 2. So if we do that, 3 times 4 is 12. And if we divide the 12 by 2, we get 6. And 6 times 2. 6 times 2 is 12. So the area of that prism is 12 centimeters cubed. Let me erase and we'll go try another one. Okay, let's go look at B. B, for the volume of it, is also going to be the area of the base times the height. This is a trapezoidal prism, so the formula for area of our base is going to be base 1 plus base 2. That's all times the height of that trapezoid divided by 2, and then we multiply it times the height of our prism. So we look over here, our base 1 and base 2, and it really doesn't matter which one's which. But we have 6 plus 14. And then we're going to multiply it times the height of the trapezoid, because that's just on the area of the base. So the height of the trapezoid would be 3. And that whole thing is divided by 2. So when we go and do that, 6 plus 14 is 20. And 20 times 3 is going to be 60. And 60 divided by 2 would give us 30. So we have 30. We still need to multiply it times the height of the trapezoid over here. Or the height of the prism, sorry. And the height of the prism is the distance between the two bases. So 30 times 5 is going to equal 150 centimeters cubed. Okay, then we have the volume of a cylinder. The volume of the cylinder is same formula. Volume of the cylinder is area of the base times the height, and we think how do we find the area of a circle? Because our base on our cylinders is going to be a circle. Area of a circle is pi r squared. So basically what we're saying is pi r squared times the height. Let's try some. Okay, to try this first one, if we know volume is pi r squared, then we multiply it times the height of our cylinder. We know that our radius is 9 and our height is 6, so we can go and just plug in pi times 9 squared times our height, which is 6. We go and multiply all those numbers together. 9 squared is 81, and 81 times 6 is going to get us 486 pi. And then we put that in our calculator and multiply that together. We should get approximately 1526.8 0.81, and that's going to be feet squared. Or, I'm sorry, cubed, since we're working with volume. Feet cubed. Let's go try our next one. Our next one over here, we know our radius is 4 and our height is 7. So we plug it into our same formula. Volume is pi r squared times our height. We can go over here and go pi, our radius is 4, so times 4 squared times our height, which is 7. 4 squared is 16. 16 times 7 is going to give us 112 pi. Then when we put that in our calculator and multiply that out, we should get approximately 351.86 centimeters cubed. Okay, here's a couple for you to try. Okay, here's a word problem we're going to work with. We're building a rectangular chest. We want the length to be 6 feet. We've got that. And we want the width to be 4 feet. And the volume to be 72 feet cubed. What should the height be? We know our formula for our volume of our prism is area of the base times the height. What shape is our base? Our base is a what shape? Our base should be a rectangle. How do we find the area of a rectangle? That is length times width. So basically, for area of a base would be length times width. And we're going to multiply it times the height. So basically, our formula for volume for this one would be length times width times height. So if we already know that we have a length of 6 and a width of 4, we just need to multiply those together. So we would have 6 times 4 is 24. H. We know that the volume they have over here to be 72. So if we're going to go and use that formula, all we need to do is go and divide both sides by 24, not 3. Let me fix that. Divide both sides by 24 to solve for our height. When we do that, 72 divided by 24, our height ends up being 3 feet. Okay, let's go and do changing in dimensions of a solid. We then want to describe how doubling all the linear dimensions affects the volume of this rectangular prism. Okay, we have our dimensions over here first, and we just found out that base times height for volume, and that's area of the base, in a sense it is a rectangular prism, will be the same as saying length times width times the height of the prism. So if we went and multiply all of those together, we're going to multiply the 4 times the 3 times the 6 on our before the change. The volume we would get would be 72 feet cubed. Okay, let's go and do this after the change over here. After the change, we're going to double each one of them. That means the 4 becomes the 8, the 3 becomes a 6, and our 6 becomes a 12. But we're going to do the same thing, still using our volume formula. So 8 times 6 times 12 is going to give us a volume of 576 feet cubed. Okay, and that is our new volume. We're going to call this one our new volume, and this one is our old volume. So if we do new over old, we're going to do 576 over 72. That's going to give us the change of 8 when we divide it. So basically it's the same as saying 2 cubed. It is doing this, doubling the linear dimensions results in a volume that is 8 times as large as the old volume. Let's try another one. Using the cylinder, and we know our formula for cylinder. Our formula for cylinder for the volume is going to be pi r squared times our height, because remember, volume formula is area of the base times the height. Okay, and they've given us a radius and a height over here. Then they ask us just to triple the radius. So let's go do the before change, or do the old one first before we go do the new one. So if we do the old one, it's going to be pi 3 times 3 squared times our height, which is going to give us 54 pi centimeters cubed. Let's go and do the change and see what our new volume would be. This is our new volume. So to do our new volume, we're going to be at pi. It asks us to triple the radius. So that means the radius, we're going to take and multiply times 3, so we're going to get a 9. So pi times 9 squared, and then multiply it times the height. Now, it didn't say to do anything to the height, so we're just going to do the change to the radius like it said. So when we multiply that out, we should get 486 pi centimeters cubed. Okay, and they want to know how many times larger is that. So we're going to go and do our new over old. Our new area is 486 pi. If we divide that by our old one, which is 54 pi, we should get a change of 9. We're not really dividing it by the pi, we're really just dividing the numbers. The 486 divided by the 54, the pi is still there, but we're just dividing the numbers. So in other words, by doing this change, it changes our volume to be 9 times the original volume, 9 times our old volume. Okay, let's go to our last example. We're going to find the volume of this composite solid, and for some reason my picture didn't come out completely, so I'm going to draw the rest of it. The bottom says it is 1.31 feet. I think that's the only thing that's missing in my picture, and yours kinda, so we know we want to find the volume of the concrete block. And looking at the concrete block, it's got 2 other little holes in it. It's got 2 other rectangular holes in it. So we're still using our volume formula, and our volume formula is area of the base times the height of the prism, and the height is the distance between the 2 bases. So if we find the area of a rectangle, we know our area of a rectangle is going to be length times width. But let's think, if we're going to find the area of this base, we're going to find the area of the large rectangle, and we're going to subtract out the area of we have 2 of smaller rectangles, so we're going to subtract 2 areas of the small rectangles. Okay, so our large rectangle, the area of the large rectangle is going to be length times width. So if I look over here, this is my length and this is my width. So my large rectangle would be 1.31 times 0.66. It's going to give me the area of my large rectangle. I'm going to subtract out, I want 2 of these, the area of the small rectangles. Small rectangles are going to be the ones we have in here. So we have our length and our width. And our length is going to be 0.33, and our width would be 0.39. Okay, if we go ahead and do just that, put that in our calculator just the way it is, we should get area of the base to be 0.6072. That's going to be the area of our base. Now in our formula, we still need to multiply it times the height over here. That's the height is the distance between the two bases, and the distance between the two bases should be 0.66. So would really technically be our big B that we just found. But for our formula, we still need to go big B times the height of our prism. So we're going to go ahead and multiply 0.6072 times the height of our prism, which would be multiplying it times 0.66, and we should get approximately 0.40. So the area of this, the volume of this composite figure is about 0.40 cubic feet, so feet cubed. And that is the end.